Hello friends. In this module, we'll be talking about the infrastructure which is required by a digital library. In this module, we will see that what are the server-side components and what are the client-side components in terms of hardware as well as software. We'll also see several digital library packages. And in the end of this chapter, we'll be discussing about role of cloud computing. Well, we all know that the primary objective of digital library is to meet the information needs of its users. Digital libraries have to be more and more responsive by maximizing the innovative impact of advancement in information and communication technology. To establish a digital library, there must be infrastructure for managing, indexing, and disseminating multimedia. A scalable technical infrastructure needs to be carefully planned to meet the functional requirement of a digital library. Hardware, server allocations, database and distribution approaches, network infrastructure, and bandwidth considerations are key in establishing the digital library as a resource that teachers, students, researchers, and the general public regards as reliable. First of all, we will talk about network and computing infrastructure. Establishing a digital library requires a great deal of computer, that is both software and hardware, and the network infrastructural components. There are no turnkey monolithic systems available for digital libraries. The digital libraries are a collection of disparate systems and resources connected through a network and integrated within one interface, and currently the de facto standard is web interface. Use of open architecture, standard, and protocols make it possible that the pieces of required infrastructure, be it hardware, software, or accessories, are gathered from different vendors and integrated to construct a working environment. While some of the components required for establishing digital library would be internal to the institution, but several others would be distributed across the internet, owned and controlled by a large number of independent players. The storage capacity of a digital library should be scalable to accommodate its ever-growing collection without requiring redesign and re-engineering of system design. The use of open system architecture provides robust system, digital library management solution, and development tools. The current servers from multiple vendors are being used by several digital library implementations for its scalability and REST features. These servers also offer high availability features such as full hardware redundancy, fault isolated dynamic system domains, concurrent maintenance and clustering support, along with offerings of modular storage capacity that can be added incrementally. A typical digital library in distributed client server environment consists of hardware and software components at server side as well as client side. The clients are machines that are used for accessing digital libraries by the users, while server hosts database, digital object, browse and search interface to facilitate its access. Now let's talk about server-side hardware components. The server are considered to be heart of a digital library. Server for digital library implementation needs to be computationally powerful, to have adequate main memory, that is RAM, to handle the expected work. It should have the large amount of secure disk storage for the databases and digital objects, and it should have adequate network bandwidth to meet the communication requirement. A digital library may need a number of specialized servers for different tasks so as to distribute the workload onto different servers. These servers could be one or more object servers to store digital objects and their multimedia objects. There can be one index servers that maintains the indices and support teaching of data stored in a distributed system, a right management system to take care of unauthorized usage and intellectual property right issue. However, for a smaller library, many distinct activities can be performed on a single server. It is equally important that the server should be scalable so that additional storage, processing power, or networking capabilities can be added whenever required. The image-based digital library implementation requires input devices like scanners, digital cameras, video cameras, and touchscreen systems. Scanners are available in all sizes and shapes. Flatbed scanners or digital cameras mounted on a book cradle are more suitable for libraries. Details on such input devices are available in the modules on digitization as well as in the module under the paper ICT applications in libraries. A digital library would require one or more servers to store the raw data, indices of metadata, so as to retrieve information from digital libraries in desired fashion. Digital library collections that are too large to store entirely on a disk use hierarchical storage mechanisms called HSM. In HSM, most frequently used data is kept on fast disk while less frequently data is kept in nearline such as automated tape library. This tape library can be robotic. An HSM can automatically migrate data from tape to disk and vice versa as required. Intelligent Storage Area Networks (SAN) and Network Attached Storage (NAS) are now available, in which the physical storage devices are intelligently controlled and made available to a number of servers. The RAID technology distributes the data across a number of disks in a way that even if one or more disks fails, the system will still function while the failed component is replaced. Digital archives may also choose to make backup copies on their own to make arrangements for other sites to serve as a backup. Although the hard disk, either it is fixed or removable, the solutions are increasingly available at an affordable cost. Optical storage devices including CD-ROM, DVD-ROM, Blu-ray or optomagnetic devices in a standalone network mode are attractive alternatives to long-term storage of digital information. Optical drives record information by writing data onto a disk with a laser beam. The media offers enormous storage capabilities. Setting up a digital library requires network and communication equipments like communication switches, routers, hub, repeaters, modem and other items required in local area network or to connect to the internet. These hardware and software items are required for setting up any network and are not specific to the digital library. Setting up a digital library requires network and communication equipments like communication switches, routers, hub, repeaters, modem and other items required in local area network or to connect to the internet. These hardware and software items are required for setting up any network and are not specific to the digital library. So far we have seen the hardware side. Now let's have a look at server-side software components. A typical digital library requires a number of software packages to handle its highly diversified resources, activities and services. Different softwares are required to handle different components and activities of a digital library. There are softwares which are required for content creation. A document capturing software is required for scanning legacy documents that are not available in computer processable file. Most scanners and digital cameras come with a basic image capturing software. The image captured in process may be manipulated or enhanced using software like Adobe's Photoshop or open source GIMP, that is GNU Image Manipulation Program. Printed text, pictures and figure captured are stored in a file as a bitmapped image, irrespective of the fact that whether a scanned page contains a photograph, a line drawing, a text. A bitmap page image is a type of computer graphic, literally an electronic picture of the page. As such, a text in a page image is not searchable on a computer. The bitmap pages are converted into textual file using OCR, that is optical character recognition software. Most document imaging software have OCR package built in. The number of OCR packages are also available as separate utilities. Converting material already available in digital format into PDF requires Adobe Software Suite or any other similar conversion software. Now let's talk about the software required for operation of digital library. Like any other server, a server for digital library requires an operating system. It may be either Linux or Unix or Windows. As digital libraries are built around web and internet technology, the server for a digital library requires a web server software like Apache's HTTPD or Microsoft's Internet Information Server. Organization of digital objects with associated metadata requires a RDBMS package such as Oracle, MySQL, MS SQL, PostgreSQL, etc. Or one can also use NoSQL packages like Cassandra or MongoDB, etc. The database management software provides structured storage and retrieval facilities to the content of digital library. Further, a digital library requires a search engine connected to the database to support searching of digital objects stored in it. In addition to this, a write management software such as Intertrust Systems Developer Kit or Active Directory by Microsoft facilitates control and monitor of access to e-contents of a digital library. Since a single integrated software package from a single vendor is not available, a digital library software may be a system with components added onto an open architecture framework. A number of digital library software are being constructed at present utilizing a mixture of information retrieval, media management, and web server packages. Some of the important software used in setting up digital library are discussed in the next slides. The first in the list is DSpace. It has been developed in partnership with Hewlett-Packard and MRT and being maintained by DuraSpace Foundation. The latest stable version is 4.0 and it's available for download on its website. The DSpace captures, stores, indexes, preserves and redistributes the intellectual output of an institution research faculty in digital formats. DSpace accepts all forms of digital material including text, image, video and audio files. The possible content may include articles and preprints, technical reports, working papers, conference papers, e-thesis, dataset, images, audio file, video file, learning object, reformatted digital library collection. That means almost everything. The Greenstone Digital Library (GSDL) is a suite of software that has ability to serve digital library collection and build new collections. It provides a new way of organizing information and publishing it over internet or on CD-ROM. It has been produced by New Zealand Digital Library Project at University of Waikato and distributed in cooperation with UNESCO and Humanities Library Project. It is open source software available from greenstone.org under the terms of GNU Public License. GNU ePrints is an open source digital library software package designed preliminary to create institutional repositories. The default configuration creates a research papers archive. It was developed at Electronics and Computer Science Department of the University of Southampton. GNU ePrints is freely distributable and subject to GNU General Public License. The Content DM from OCLC is a multimedia software suite that provides easy loading, management, and access to media archives in a library. It provides tools to assist with every phase of collection development. Content DM can handle databases with millions of objects. The Fedora Flexible Extensible Digital Object Repository Architecture Repository System is an open-source digital object repository system developed jointly by University of Virginia Library and Cornell University, and now being maintained by DuraSpace Foundation. The Fedora project is devoted to the goal of providing open-source repository software that can serve as foundation of many types of information management system. The software demonstrates how to distribute digital information management can be deployed using web-based technologies, including XML and web service. So far we have seen server-side hardware and software components. Now let's have a look at client-side hardware and software components. As told earlier, clients are the machines that reside on users' desk or laptops or tablets. The planners of digital library need to prescribe minimum level of hardware and software that a user would require so as to achieve efficient and effective interaction with the digital library. Most digital libraries require an internet-enabled multimedia PC or a tablet equipped with internet browsers like Internet Explorer, Mozilla Firefox or Google Chrome as their clients. The client-side PC may also require following group of software packages or plugins to be downloaded from format-specific deliverable from a digital library. The software listed here are based on their categories. You need internet browser, PDF readers, you need a software for playing audio and video files, you may need a file transfer client, you may need software for display and printing of Word, PowerPoint and Access document, you need an image viewer as well as image manipulation and editing program as well as video editing program. The cloud computing can be understood as a way to use off-site computer processing power to replace content creation and servers that were traditionally hosted on-site. Cloud computing allows content creation to be made when data and software application resides on and are drawn from the network rather than locally on any workstation. The cloud computing can be advantageous and it will increase the ability of a library to try out new software without having to buy the hardware as well as being able to scale the computing power to meet the demand of users. A library can increase quantum of cloud computing they require by contacting the vendor instead of physically acquiring new hardware to meet the increased demands. The general advantages of having digital library on cloud are compliant facilities and processes, cost effectiveness, enterprise-grade service and management, faster provisioning of systems and applications, flexible and innovative, flexible and resilient in disaster recovery, highly secured infrastructure, reduced hardware and maintenance cost, round-the-clock access, simplicity of integration, and simplified cost as well as consumption model. The general advantages of having digital library on cloud are the server-side hardware compliant facilities and processes, cost effectiveness, software components, enterprise-grade service and management, hardware components, faster provisioning of systems and applications, flexible and innovative, flexible and resilient in disaster recovery. We have also seen highly secured infrastructure that how a cloud computing hardware and maintenance play a vital role round-the-clock access, simplicity of integration, planning a digital and simplified cost as well as consumption model.